This lecture is about the feedback in the vector space model. In this lecture, we continue talking about the feedback in text retrieval. Particularly, we're going to talk about feedback in the vector space model. As we have discussed before, in the case of feedback, the task of a text retrieval system is to learn from examples to improve retrieval accuracy. We will have positive examples. Those are the documents that are assumed to be relevant or judged to be relevant, or the documents that are viewed by users. We also have negative examples. Those are documents known to be non-relevant. They can also be the documents that are skipped by users. The general method in the vector space model for feedback is to modify our query vector. Now, we want to place the query vector in a better position to make it accurate. And what does that mean exactly? Well, if we think about the query vector, that would mean we have to do something to the vector elements. And in general, that would mean we might add new terms, or we might adjust weights of old terms or assign weights to new terms. And as a result, in general, the query will have more terms. So we often call this query expansion. The most effective method in the vector space model for feedback is called Rocc feedback, which was actually proposed several decades ago. So the idea is quite simple. We illustrate this idea by using a two-dimensional display of all the documents in the collection and also the query vector. So now we can see the query vector is here in the center, and these are all the documents. So when we use the query vector and use a similarity function to find the most similar documents, we are basically drawing a circle here, and then these documents will be basically the top ranked documents, and these pluses are relevant documents, right? And these are relevant documents. For example, this relevant, etc. And then these minuses are negative documents like this. So our goal here is trying to move this query vector to some position to improve the retrieval accuracy. By looking at this diagram, what do you think? Where should we move the query vector so that we can improve the retrieval accuracy? Intuitively, where do you want to move the query vector to? If you want to think more, you can pause the video. Now, if you think about this picture, you can realize that in order to work well in this case, you want the query vector to be as close to the positive vectors as possible. That means ideally you want to place the query vector somewhere here, or you want to move the query vector closer to this point. Now, so what exactly is this point? Well, if you want these relevant documents to be ranked on the top, you want this to be in the center of all these relevant documents, right? Because then if you draw a circle around this one, you get all these relevant documents. So that means we can move the query vector toward the centroid of all the relevant document vectors. And this is basically the idea of Rocc. Of course, you can consider the centroid of negative documents, and we want to move away from the negative documents. Now, geometrically, we're talking about moving the vector closer to some other vector and away from other vectors. Algebraically, it just means we have this formula. Here you can see this is a original query vector, and this average basically is the centroid vector of relevant documents. When we take an average of these vectors, then we're computing the centroid of these vectors. And similarly, this is the average non-relevant document vectors, so it's the centroid of non-relevant documents. And we have these three parameters here, alpha, beta, and gamma. They are controlling the amount of movement. When we add these two vectors together, we are moving the query vector closer to the centroid. Right? So when we add them together, when we subtract this part, we kind of move the query vector away from that centroid. So this is the main idea of Rocc feedback. And after we have done this, we will get a new query vector which can be used to score documents. This new query vector will then reflect the move of this original query vector toward this relevant centroid vector and away from the non-relevant centroid vector. Okay, so let's take a look at the example. This is the example that we have seen earlier, only that I dimmed the display of the actual documents. I only showed the vector representation of these documents. We have 5 documents here, and we have 2 relevant documents here, right? And they're displayed in red, and these are the term vectors. I have just assumed some TF IDF weights. A lot of terms will have 0 weights, of course. And these are negative documents. There are 2 here. There is another one here. Now, in this Rocc method, we first compute the centroid of each category. Right? So let's see. Look at the centroid vector of the positive documents. Well, we simply just, so it's very easy to see. We just add this with this one, the corresponding element. And then that's down here, and take the average. And then we're going to add the corresponding elements and then just take the average. Right? So we do this for all these. In the end, what we have is this one. This is the average vector of these 2. So it's the centroid of these 2. Right? Let's also look at the centroid of the negative documents. And this is basically the same. We're going to take the average of 3 elements. And these are the corresponding elements in the 3 vectors, and so on and so forth. So in the end, we have this one. Now, in the Rocc feedback method, we're going to combine all these with the original query vector, which is this. So now let's see how we combine them together. Well, that's basically this. Right, so we have a parameter alpha controlling the original query term weight. That's 1. And then we have beta to control the inference of the positive centroid vector weight. That's 1.5. That comes from here. Right? So this goes here. And we also have this negative weight here, controlled by gamma here. And this weight has come from, of course, the negative centroid here. And we do exactly the same for other terms. Each is for 1 term. Right? And this is our new vector. And we're going to use this new query vector, this one, to rank documents. You can imagine what would happen, right? Because of the movement, this one would match these red documents much better because we moved this vector closer to them. And it's going to penalize these black documents, these non-relevant documents. So this is precisely what we want from feedback. Now, of course, if we apply this method in practice, we will see one potential problem. And that is the original query has only 4 terms that are non-zero. But after we do query expansion, you can imagine we have many terms that would have non-zero weights. So the calculation would have to involve more terms. In practice, we often truncate this vector and only retain the terms with the highest weights. So let's talk about how we use this method in practice. I just mentioned that we often truncate the vector. Consider only a small number of words that have highest weights in the centroid vector. This is for efficiency concern. I also said here that negative examples or non-relevant examples tend not to be very useful, especially compared with positive examples. Now you can think about why. One reason is because negative documents tend to distract the query in all directions. So when you take the average, it doesn't really tell you where exactly it should be moving to. Whereas positive documents tend to be clustered together, and they will point you to a consistent direction. So that also means that sometimes we don't have to use those negative examples. But note that in some cases, in difficult queries, where most top-ranking results are negative, negative feedback actually is very useful. Another thing is to avoid overfitting. That means we have to keep relatively high weight on the original query terms. Why? Because the sample that we see in feedback is a relatively small sample. We don't want to overly trust the small sample. And the original query terms are still very important. Those terms are typed in by the user, and the user has decided that those terms are most important. So in order to prevent us from overfitting or drifting, prevent the topic drifting due to the bias toward the feedback examples, we generally would have to keep a pretty high weight on the original terms. It's always safe to do that. And this is especially true for pseudo-relevance feedback. Now, this method can be used for both relevance feedback and pseudo-relevance feedback. In the case of pseudo-feedback, the parameter beta should be set to a smaller value because the relevant examples are assumed to be relevant. They're not as reliable as in relevance feedback. In the case of relevance feedback, we obviously could use a larger value. So those parameters still have to be set empirically. And the Rocc method is usually robust and effective. It's still a very popular method for feedback.